Let's work on this easy problem, guys. It says let vector A is given to you as, I can see that in the board, it's like vector A is given as I plus 2j. Okay, and the second vector B is given as 2I plus j. Now the question is, are their modulus equal? It means, is the length of vector A equal to the length of vector B? Now how will I get that is? Right, is the question, simple as that. Now I know that modulus of vector A is nothing but how long is that line. Basically, if I see here in the vector the diagram, I can see this is vector A, and I just want to see what is the length of this line basically. And how to get that? That's a simple formula that goes like vector modulus of x squared plus y squared, and that is x for me, which is 1. I can write 1 squared plus that is y, which is 2 squared. Well, that's it, guys. It's pretty simple. I can write that is nothing but root of 5. So the modulus of vector A is root of 5. Makes sense. So how do you write the modulus of vector B now? It's again same thing. Modulus of vector B is simply given as root of, I can write x squared plus y squared. The formula goes like that. Then x is 2 and y is 1 in this case. So that's 2 squared plus 1 squared square root. That goes like root of 5. Now I can see that the modulus of B and modulus of A is same. Makes sense. The first question is answered here. I can see that that's the first question. Is the modulus of A and the modulus of B equal? Yes, they are equal. I can say that's root 5 and root 5. Now the question is, are the vectors equal? Now look at this. I can see these are the exact vectors I'm talking about. That's 2. I can see that is 2i plus 1j, and that's like 1i plus 2j. But they are equal. They are not equal for a reason that they don't have the same direction. Now when can they be equal is the question. Let me just draw two vectors which are equal in length, all right, and direction both, and those are called equal vectors. For that, the components should also be equal. So if I just move this guy like that, now look at this. This is 1, 2 and 1, 2. It means it's 1i plus 2j, 1i plus 2j. And if I move this vector and the other guy, now I can say these are exactly equal vectors. So what is the condition for two vectors to be equal? This is not enough. Their length can be same, but I can see that the direction is not same. So how will I get to know that? If I know that that's vector A and vector B, their components should also be equal. So x component of this guy is 1, should be equal to this guy. If they are not equal, then I can say that vector A and vector B are not equal vectors, but their modulus is definitely equal. Right, very simple, guys. Let me put this back again to show you that. So now if I move it here, now I can see that is 2, 1 and that is 1, 2. All right. Now to see why are they different, basically because of the direction is different. I can see that. See, this is like I can write the vector A as this is I here, and this is 2j. So the vector moves like I and 2j. So that's different from this guy is like 2i, that is I plus I, and that's like j. So that's how we write this guy. This is like 2i plus j, and this guy is nothing but I plus 2j. For vectors to be equal, as we know right now that the components should be equal, it's not enough their modulus is equal. Very simple, guys.